Hello everyone, this is to say my fortunate Agnes, once again a student at Makerere University, pursuing a degree in software engineering. I'm currently in my second year. Like we did last time, again I've come back with how best we can solve traffic jam using traffic lights around us. How can we improve our traffic lights? What can we add? What can we improve in traffic lights so that we have a traffic jam-free environment? So first of all, we need to know how traffic lights operate. Basically, an inductive loop is embedded in the road surface, like it's put inside the road. Okay, like they dig and they place it inside, and it acts as a magnet. So every time a car stops over a loop, the metal in the car reacts with a magnet, and this changes the magnetic field. So every time the magnetic field is changed, the wire notices that it notices the change and tells the signal controller that a car is present, thus turning the traffic lights to green. Traffic light detection dataset. This is the dataset that I've used. It is based on CCF BDCI and is used for traffic light prediction. This dataset contains over 2,600 artificially labeled traffic light categories and color labels. The traffic light category includes the following categories, among which are motor vehicle signal light, non-motor vehicle signal lights, left turn, non-motor vehicle signal lights, among others. We have limited time. Factors considered, these are some of the factors that I've considered while selecting my data set. First and foremost, it's big enough. Its sample size is enough. And every time a data set is big, it has sufficient data, thus producing an accurate system. Then my second factor was research goal. It all goes back to what you as a programmer, what do you want to achieve? What system do you want to design? That's what you depend on to look for as a data set, because you couldn't get any random data set and find that it corresponds to your set goal. So every time you're looking for a data set, you have to bear in mind, what is my goal? What do I want to achieve? What do I want to program as a programmer? What system do I want to come up with? So a data set is selected based on the system a programmer is aiming at building. So these are some of the features that my AI model is likely to use while solving the real-life problem. The real-life problem are traffic lights. So it's going to use images, signal lights, flash warning light, and magnetic field. Like I told you in the previous video, images they are taken by a small camera that is inserted inside the traffic lights, and these images are for vehicles. Like this small camera takes the different pictures of vehicles in different lanes and sends them to the database. So it's this database to decide which lane has the longest line of vehicles, which lane doesn't have a single vehicle, which lane actually needs to be released. You get my point. Then the second feature was signal lights. Signal lights works almost like images. This is just to be efficient enough, not to depend on only images. What if the camera fails? What do? We depend on signal lights. Then flash warning light. This warning light is basically for drivers and maybe pedestrians. Just alert them about traffic lights. What are they communicating in the nearest time possible? Are they almost releasing us? Are they almost telling us to stop? Are they telling us to get ready? Stuff like that. Then it also uses a feature that is called magnetic field. Like I explained before, every time the magnetic field changes, the wire notices it and it sends a communication to the system, implying that a vehicle is around or vehicles are around so that they can be released. Then how can we describe Bayesian theorem? Bayesian theorem, it just states that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first, multiplied by the probability of the first event. Like you see mathematically, you guys have seen this. Probability of A given B is equal to the probability of B given A multiplied by probability of A divided by probability of B. That's the mathematical expression. How can Bayesian theorem be applied in the betterment of traffic lights? This is how we do it. We develop traffic light system based on Bayesian interpretation of probability that is adapted to the high dynamics and non-stationarity of a road network. Then, how can you describe naive Bayes? Naive Bayes is a machine learning algorithm we use to solve classification problems. It's based on Bayes' theorem. It's one of the simplest yet powerful machine learning algorithm in use and finds many applications in many industries. So application of naive Bayes, it's used for making predictions and forecasting data based on historical results. Again, naive Bayes assumes that the presence of a particular feature in a class is unrelated to the present, as in it's independent. It doesn't depend on anything. Then how do you describe Bayesian networks? How do you describe it? It's a probabilistic graphical model that represents a set of variables and their conditional dependencies via a directed acyclic graph. It can be used to build models from data and/or expert option. It can also be used for a wide range of tasks, including prediction, anomaly detection, diagnostics, among others. Then application of Bayesian networks in traffic lights. In traffic lights, Bayesian networks is used to realize online reasoning and determine the best traffic light time. The algorithm combines the time window and the improved forward-backward algorithm. Differences between Bayesian theorem and naive Bayes. First and foremost, the occurrence of an event in naive Bayes is independent of any, it doesn't depend on anything. It will happen whether the other event occurs or not. But as for Bayesian, it is conditionally dependent on the other through conditional probability. Like for the occurrence of a certain event is dependent on the occurrence of another event elsewhere. Then the second difference is Bayesian theorem deals with a comparison of different family of algorithms, whereas naive Bayes deals with a family of algorithms, not a single algorithm. Then I also have differences between naive Bayes and Bayes networks. Naive Bayes, like I told you, works best with imbalanced datasets, whereas Bayes networks operates with balanced datasets. Every pair of creature being classified is independent. Like we had said before, everything in naive Bayes happens independently of the other relationships. Whereas in Bayes networks, relationships are modeled between features in a very general way, and they have enough data to derive them. Ladies and gentlemen, these are some of the references to my work, just in case you felt like reading more, you want to gain more knowledge. These are some of the references. Please, thank you for watching. Please subscribe to my YouTube channel, like, comment, hit the subscribe button. Thank you so much. Have yourselves a blessed day.